let's continue. Okay, let me open the table of content first. Alright, we are still in chapter 18 here, still on homework simulation section. Let me open that. Okay, we already take a look at this. We already take a look at this too. And now we are taking a look at this. The question 3. I think previously we tried out with this flag. Let me open that. Okay. Let me open my terminal emulator. And okay. What is the script name again? Patching linear translate. Okay. Okay. Oh, I think previously I tried out using 512 megabyte. Well, let me try again. Is there any different? Okay, thing like this, and then wait, 32K. Okay. I don't think there is any different with the virtual address. Well, let me compare. Okay, looks like there's no difference. Okay, and then let's change this to 25. Again, if we check patching linear here, this U is the percentage of virtual address space that is used. So previously when we put this 0 with this U flag, basically we are using 0% of the virtual address space being used. And now we are trying to use 25% of the address space used, I guess. And I don't think there's any different. Let me check. Okay. Yeah, this looks like nothing different too. Okay. Well, let's just see what is it called? The physical memory. This one. The physical memory of 32K instead of 512 megabyte. And now how do we... Oh, this one is different though. Okay, interesting. Okay, let me show that, I guess. And this one. Inductive this. See, there is some difference here. Right. Okay. So maybe using the physical trace of 32K can make things easier to analyze. Something like that. Hello, Anna. Is this the S2 material? I'm assuming S2 in here the master degree. I don't think so. I think this is the, what is it called? The undergraduate material, maybe something like that. But yeah, I'm just learning this because I'm curious, I guess, not because any of the education reason. So yeah, I'm not sure if this is the master degree material or not. Okay, oh, okay, wait a minute, let me check the readme. We have this one, and then wait a minute. Okay, because base stable is in linear array. Alright. How do we translate this? Okay. Wait, I already read the info here. Oh, yeah, I didn't put that. Okay. Yeah, previously I'm kind of curious how we decide the virtual page number here from this hex number or the decimal number. Yeah, previously I'm curious about that. Like, why is this virtual page number 3? At first I'm assuming from this one, but then the calculation of this, see, why is this virtual page number 14? And this one virtual page number 10. How do we decide that? Is this from the decimal number here? Yeah, that's something I'm still not sure previously, so let's try to figure that out now. Okay, we have the page size 1K, right? We have the page size 1K. So maybe when we have this, right? What is it called? Its page is 1K, maybe something like that, until maybe 99, and then this one 1000 or 1K until maybe something like this. And then we are increasing this one. Maybe I'm not sure if this is correct or not, but let's try that. Okay. Let me put this. Or maybe I just use something like this. Six. Wait, okay, 6. Alright, now we have 12. And then 3 more. Okay, maybe something like that. Okay. Alright. And then maybe something like this. No. Alright. Okay. Maybe like this one. Okay. And then this is for 14,729. So maybe in this range, I guess. Is that it? That's why we have the virtual page number 14. And for this one, 11,206. It should be this one, right? So why is this virtual page number 10? What is going on? And this one is virtual page number 1, okay. But why this one is virtual page number 6? I am kind of confused, I guess. Hello, Turtle. Hello, DR Wolf. Are you learning assembly? What? Not necessarily assembly. I'm learning the operating system concept. With this book, Operating System 3 Easy Piece, and currently we are on chapter 18, learning about paging and trying out the homework simulation here. Basically, there is the script, the Python script that, what is it called? That simulate how the virtual to physical text translation with linear page table. I'm assuming there are other kind of page table, but currently we are using the linear page table concept for the simulation. And now I'm trying to understand how this simulation decide the virtual page number, which I'm kind of confused. So yeah, there's that. Is this concept the same in all operating system? Honestly, I'm not sure. I assume this might be the same, at least in the Unix-like operating system, like Linux and maybe FreeBSD, something like that. I'm not sure about Windows, so there is that. Yeah, maybe it is the same. I'm still not sure. Okay. Why is this virtual page number 6? That is and not 7. Did I miss something here? Wait, if I remember correctly, okay. Can I do this? Okay. Right. Okay, page size 4K. Okay, the space size 6K. I'm assuming maybe something like this. Oh, wait a minute. Are we not using the decimal representation but binary representation? Maybe. If that is the case, Wait, let me try something. Okay, D5, maybe something like this, and D6, and then should I do this? I don't think so, I guess. Yeah, maybe something like that. And then okay. But if I do this, we are already hitting the 16k. Is this right? We have 4, right? And we split that by 4k. Let me try using the decimal representation here. Okay, and then maybe something like this. Oh, right. Okay. And then thinking something like this maybe. Oh, sorry, this one, right? Should be like this. And then something like this. Okay. Yeah, I'm still trying to figure things out. 4096 maybe. Okay. Okay, maybe something like that. And now I think again. Alright. 3, maybe something like that. Okay, and then we take a look at this one. 12,000. It should be in this virtual page number, right? Wait a minute. N3, virtual page number 3, and then for this one, virtual page number 1, I guess, and then this one, virtual paste number 2. Okay, virtual paste number 2 again. Oh, wait a minute. This is not virtual paste number 2. This is virtual paste number 1 in this range, right? And then we have this one, virtual paste number 3. Okay, maybe something like that. Let's check. Okay, virtual paste number 3, right? And then this one is virtual paste number 1. Okay, virtual paste number 2, and then virtual paste number 3 again. Okay, maybe something like that. And now we have this one, 16K, but 1K page size instead of 4K. Okay, so right. Okay, maybe we are using the binary representation here. It is kind of tricky to calculate. Okay, maybe something like this. Until, okay, wait a minute. Okay, I'm just making sure. Right, okay. Oh, interesting. Yeah, if we are using the binary representation instead of the decimal representation, we kind of having different starting point, I guess. Page number 2 here, but we are starting out from the 3072 address, something like that. Okay, maybe that is what happened here. Maybe. Oh. Okay. And then 19. 20. Okay. Yeah, we are doing this manually to understand what is going on. So bear with me. Yeah, in the meantime, you can also analyze this yourself. I mean, I might be wrong, you know. Just something to keep in mind. Okay. Right. I always forgot to reduce one number from the actual value here. Okay. 9. interesting. In the page number 8, we are already hitting 10,000. Is my calculation correct here? Wait, I don't think it is correct. Yeah. Okay. Well, let me revise that. See, I might be wrong. Okay. So yeah, you need to analyze this yourself too, in case I'm also wrong. In case I'm wrong, right? Okay. All right. Yeah, maybe something like this. Well, the point is that we need to know when we are wrong. Okay. 68. Something like this. Okay. 39. Uh, 40. Okay, something like that. Okay, 7. Wait a minute. Okay, 15. Okay, maybe something like this. And now let's take a look at this again. 14. What is it called? 14,729. This one. So it is virtual page number 14. Okay. Yeah, currently let's try what is it called? In which page number the address reside, something like that. Okay, I think no, not this one. Oh, okay, yeah, it is 11,206, I guess. So that's why it is in here. Okay. And it is in the virtual page number 10. And then for this one, 7,735 is in the virtual page number 7 here. Okay. And then 1,649. Oh, okay. This in the virtual page number 1 here, right? Then 7,113. It is not in this one because we are starting out from 7,168. So it is in this one, virtual page number 6. Okay. Alright. Let me put this here, I guess. What is it called? Range in one page when the space size 16K and what is it called? Page size 1K. Yeah, maybe something like this. Okay. 16K. Okay, so at least we know how, what is it called? How to look for the virtual page number with this address, virtual address. Okay. Alright. What is the question again here? What happens as you increase the using bit format? Did it work using bit format? What do you mean by bit format here? The binary format? Like, what is it called? 101, something like this. I'm not sure if we can understand that using the binary format. Maybe we can, but yeah, I'm not sure yet. I mean, usually the address is in the what is it called, in the hex format here. So there is that. Yeah, I'm still not sure how to read this hex format. Okay. Wait a minute. And now how do we add the offset? Right. How do we set the offset then? Okay, let's try that out first. Okay, we are in the virtual. Okay, let's try this. The valid one in virtual page number 10. We next look in the page table to see if alright, physical page 6. Thus we can form our final physical trace by taking physical page 6 and adding it to the offset. So we are taking this and adding it to the offset. Shift that into a proper spot. So maybe we have something like this. Oh, wait a minute. Or or by this one, PCT maybe. PC6, I mean. Is this it? Is this gonna become something like this? No. How do we get this? Let's hexadecimal converter. How do we get this? You know what? Maybe we can do something like this, I guess. I want to see 9216. Is this what this X number Oh, wait a minute. 19. Okay. Not that one. Okay. Wait, let me change that. Okay. Convert 20. Where is this come from? Hectesimal calculation, maybe something like that. Yeah, I'm not sure how to add the offset here to this one. Okay. 2014. I mean, if I do this, right? It doesn't really. Okay, it's really matter here. Okay, interesting. So yeah, how do we get the 20,000 here? That is the question. And how do we use the OR here? Is this the one? Let me check. Okay. Logical equation, maybe something like that. What is a computer? Yeah, I mean, how do we to set the offset again? Let me check in here. The virtual page number and the offset within the page. And the offset within the page. Okay. The offset within the page. Maybe the what is it called? Maybe the offset is 206. Maybe, or maybe not. Maybe, well, let me try this. So this is the address, right? And the base for this page is 10,240. Or maybe we are starting out from this. And yeah, how do we read this? I have a lot of questions. Okay, let me question about the simulation, I guess. How to read the hex number from page table, and then how to determine the offset. The offset from the virtual address. Maybe something like this. Alright. Maybe I need to look at the code to understand the calculation. Okay, VPN marks. Well, you know what? Let's continue this on the next session. So that's it for now. Thank you for watching and see you next time. Bye bye.